Hi, I'm joining you from just north of Boston, Massachusetts. And I work at Intel, but today I'm representing the Linux AI and Data Foundation's OPEA project. And I am very happy to do so because I think it's something that is going to be helpful for you in adopting GenAI. So as everyone knows, GenAI came out of nowhere, frankly, or maybe for those in the know, people saw it coming. But for a lot of us, it came out of nowhere, right? And a lot of times when there is a new technology, it's great, it's shiny, it's wonderful. Everyone wants to incorporate it. But if you're in an enterprise, there's lots of things that you need to be thinking about when you take on a new technology. I know a few years back, there was a discussion around sort of if you build something net new, you don't want it to be all the new and shiny. Like you can have one new and shiny and then some sort of like core older stuff that you really know your way around. So with generative AI implementation, especially in the enterprise, there's just technical implementation issues, right? So first of all, you need to have your data in place and accessible to even get to the point where you can incorporate AI, right? Generative AI. You also need to think about where can I use this that it isn't just tacking on. So it isn't like your next product with AI, right? So where does it really make a difference? There is a cost. It is not cheap to run generative AI. So there's definitely time and budget implications to think about. There has been a dearth of talent in the AI space because it has been changing so rapidly. It has grown so rapidly. So that's another thing that enterprises are looking at. Then, let's say you do have your data all set, you have data governance in place. Then you need to think about AI governance, right? So that's a whole another thing that you need to be thinking about. You need to think about, okay, great, we know a reason we want to use it. We have everything in place. Okay, now we need to figure out how we want to deploy it, put it into production. And you need to think about resiliency and security, being able to take a look at what it's doing while it's doing it. Observability, one might call that. So really thinking through that. So because of that, we thought that open source. So open source is really part of the fabric of Intel, and it's one of the reasons that we donated it to the Linux Foundation. And so we think that open source is the way to do this. And so RAG is where we started with OPEA. RAG has become very, very popular. You probably know that if you're here at this virtual conference. So, we have a very simple, or not so simple, workflow showing RAG, right? That is making use of LLMs, right? So it's basically a way to utilize an LLM and make it a little bit more trustable and usable, right? So you're basically anchoring it with knowledge that is correct. Your business might have a data set. There might be data sets where they're trustable data sets, right? And so if the LLM is grabbing its information from something like this alongside other things, then that there's a better chance that it's not going to hallucinate. It's something that you can trust. And so vector DBs are the way that this has become standard. So that's so one example of that is Milvus. So like I said, the reason to use RAG is LLMs, at least today, need guidance. And so most companies have an amazing amount of data that can be very, very useful. And AI is one thing so far that they can do this better than us, right? They can really go through there and look in and find out, what's needed. And so, vector DBs really can do this well, and they're a part of a RAG workflow because they can go in there and they can account for the meaning and context. They can go through large amounts of data. they can look at similarities. So they're really great. So RAG has really become sort of a standard way to go in and find answers in chat Q&A applications using it, for instance. So OPEA came along and is hopefully what you will see is a framework for how to pull this together, right? So it's created from, this has got some fun stuff. So basically, it's a framework of these composable building blocks. So if you remember the workflow that we saw in the previous slide, it showed different pieces, right? So basically, all of those different pieces can be swapped out depending on your needs or what you're familiar with or what you already have in your ecosystem. So OPEA provides, right now, I think we have maybe about 16, 17, 18 end-to-end examples that showcase, how you can do chat Q&A with Milvus, how you can do a chat Q&A with Quadrant, just all different things, right? And so this idea that all of these different newfangled companies that have come out with really awesome, products, we ensure that they're easily swapped out, and you can, not only are we giving you sort of like the map, but we're giving you the different routes that you can take, right? Take a left here, you want to use this piece. Take a right here, you want to use this piece, right? So we have all of those different pieces, like the prompt engines, data stores, et cetera, right? And we have those workflows. A lot of times when technology, again, comes on, it's not that you want to add it because it exists, right? You want to make sure that you're incorporating it in some way that really makes sense, and that it is additive to the point of it, like threads through like business value, right? Like reasoning. It's not just like a cool thing to do. So another piece that we're working towards, and I know is a little bit less mature than the other two pieces that we have, is sort of like an assessment or grading system for Gen AI systems. And so you can see here for enterprise, we believe performance, certain features are necessary, trustworthiness, which is where you're seeing like security and resilience, and then enterprise readiness. And so this is going to be more about being able to evaluate your own system. It's going to be able, like, eventually the idea would be to say, oh, that's an OPEA 3, meaning, it's fast enough to answer questions, like this, but if things are too complex, then you're going to need something else, right? So it's basically another way to start to look through and categorize different workflows in the Gen AI space. So more on that soon. So if you look at the architecture, like I was saying, it's all of these different little microservices that you can use. So it's really easy to pull them out and use them. And then the engineers are pulling that together and calling that one mega service. And then there's a gateway, and then there's a little smiling you. So it really simplifies the way things are done. And what I think is great is it's simple, and then you can build upon it and make it more complex as you need to. A lot of times you really don't have to, and you'll see that when you take a look at all the different examples. So what's been really cool is, like I said, we started with RAG workflows, but we have wanted for the past few months, and OPEA only started in April. It was based on some work that was done, and it went into the foundation in April. So we've been wanting to pull together GraphRAG examples, right? So GraphRAG is something where knowledge graphs are introduced, and it's additive. So this actual GraphRAG pattern I pulled from Neo4j's GraphRAG manifesto, which I truly enjoyed. And what's cool about knowledge graphs is that, so my understanding is vector TVs are great when you need to go in and grab something. Like, I need this answer, here's this one specific answer, great. If you have sort of a global question that's a little bit more nuanced, a little bit more complex and unique, it's a knowledge graph, and the way that data is stored in that graph is better when you need to sort of build the answer, right? It can merge together a couple of different pieces of data to get you a better answer. So I think of it as sort of like more robust. So I think this is a natural place for us to go next. And so what's great is that I'm going to show you two examples. The first one is one that we've been working with Neo4j, and it is from Andreas, who is the lead there for AI generation, I believe, innovation. And so he is working on a pull request for a multi-agent system. And so it's really cool. So you query the supervising agent, right? And then it tells you, it goes to all of these different tools, right? It goes to the worker agent that does its thing, but it can also go to these other tools. And I wrote down what these could be. Oh, it could be knowledge graphs, could be SQL databases, it could be other sorts of databases. So it's really, again, sort of like crafting together that answer for you to get a better quality answer. And we have a lovely demo from him. Nothing, so it's pre-recorded, so the demo can't go wrong. But let's see what happens when I hit the video. I'm going to try and make it full screen so that you can see it really nicely, and I'll shut up.
I'm so excited to be working with OPEA, collaborating together.
Okay, that's weird. Let me try that one more time.
Knowledge graph.
No, okay, let's try this. Hold on. Sorry.
We could hear that one.
Yeah, it was double, it was like echoing. Was it not echoing?
I didn't hear an echo, no.
Okay, well, let's get right back to it then. Now I won't be able to find it, but hold please. Where the heck? Huh, here we are. Sorry about that. I knew whatever I'd do. Well, tell me if you hear an echo, would you? Okay. There we go again.
The screen share, you've quit your screen share.
Oh, no, okay, sorry. One moment. Screen share. Got it. I knew I would mess this up. I apologize. Okay. One more time.
Microsoft architecture for production-ready GenAI applications. The example that we're working on is, of course, a GraphRAG example. Let me walk through the workflow so you know what's going on here. We've got, of course, user input, and because this is an agent-based, workflow that we have here, the user inputs can go to a React agent. That's the, reasoning and then acting agent supervisor itself. That's going to interact with the LLM service, a microservice that, is the fronting of the LLM to figure out, okay, given this user input and these tools that are available, which tool should I use to try to, get an answer for the user here? We provided two tools in this initial example. One focused on unstructured data that uses a combination of vector search with pattern matching, and the other that does structured data queries. Of course, this is a text to cipher based tool. The unstructured data tool makes use of an embedding microservice and also talks directly to the knowledge graph microservice. The structured data tool reaches out to the LLM to generate a query for the user's input, runs that cipher query against the knowledge graph microservice. That's the overall flow. Let's take a look at what this is like in action. Of course, the data set that we're using here is my favorite. It's the Edgar data set. This is the SEC financial filings, in the United States. So we have financial filings from publicly traded companies and also the investors in those companies. So we can ask questions like, what companies are in California? Are in California. And this is an agent-based approach, of course. So you can see that first thing that happened there in the tool selection was the agent's like, okay, given the question that was being asked, let's scroll back up here. It decided, okay, I can use the graph cipher QA chain to query about the location of companies in California. So that's the action that it took. And here's the cipher query that was generated by the LLM. It does a match for a company that's located at some address, where that address state is California, and then just return those. given all that and the data set that we have, it's a small data set. Here's what it came up with. So a couple of companies that we know are in California. Let's ask a little bit more about NetApp. So we know we have financial filings here. So what is NetApp's primary business? That's one of the things they'll have to state in their filings with the SEC. Okay, here it's again, let's use the company retriever tool. So different this is the first tool that it actually does the combination of vector search and then pattern matching. So instead of the text decipher tool that was used the first time around. And it got information back from the filings, from the unstructured data, and then used that for producing a final result. Fantastic. Okay, let's ask it a little bit more tricky question. Something that we know is not in the unstructured data that you can only answer if you have a combination of unstructured and structured data. So tell me about what NetApp's investors. So what are NetApp's investors? I'll spell that correctly and I'll say who are. I'll try to help the LLM out with some proper English. Okay, again, it uses the company retriever tool. And the thought, of course, here was it realized that the retrieval tool is able to find information about investors in addition to companies. And so that's what it called out to. And it found out the information that it needed. And here's the investors in some interesting added text. Well done for the LLM there. Okay, we'll go a little bit deeper here. We'll ask some questions about what are the risks to companies. So not about a particular company, but which companies are something. So let's say what companies are at risk from a chip shortage. And that's going to go ahead and run. And hopefully it'll select the same company tool. Or perhaps it'll just take a little nap. There it goes. Okay. So it often used the company retriever tool. So here's the thought that it had. It needs to find information about companies. It knows it can use the company retriever tool for that. Perfect. It does the query for that, which ends up being a vector similarity search to find, some companies will have talked about what their risks are. And so we found Western Digital. Oh, and also Palo Alto Networks. Okay, great. Now we'll do the same thing again. Can we combine this, query about risk all the way to the investors? Let's try that. So not companies, but what investors are exposed to a chip shortage? Okay, and let's take a look at the reasoning here for a second. So to answer this question, find companies affected by the chip shortage, and then identify their investors. Great. So it's going to start by identifying companies affected by a chip shortage by using the company retriever tool. That's good. Curious that it found Nike Incorporated. I think it's probably mistaken on that one. But digital, okay, yeah, that's completely right. And then its final answer are based on since Nike and Western Digital. Here's the investors in that. Now, it got Nike wrong, so we need to have an extra little challenge in there to make sure that when it finds companies that are at risk, say, hey, are you sure? Is this company actually at risk from a chip shortage? I don't think that's really affecting Nike's shoe business. But okay, we'll give it a pass on that for now. This is some more improvements we can do to the prompt engineering. But the overall flow made sense, and actually the tool use made sense. And more importantly, all of this is actually designed to take advantage of all the microservices that you have within OPEA. So this is production ready. Once you've got all of the different guardrails in place, this is something that can scale completely for production. Hope you enjoyed that. Thanks.
Okay, awesome. So that is functionality that the OPEA team is working on right now. So that's really awesome. So now, let's see. What we do have at the moment is the GraphRAG. So Microsoft came out with its own GraphRAG solution as well. And so we just mentioned that here. It's from this paper, and it's a little bit different. It's a little bit more involved if you don't have knowledge graphs already in place. The thing to know about GraphRAG in general is it's going to the LLMs multiple times, which makes it more expensive and takes a little bit of time. But as you can see, it was pretty fast. And so I'm going to show you another demo that does not have a narrative, so I will just chime in periodically. But I wanted to show you this because this is literally it working. And today, like you could go check this out today at these URLs below. So let's see if I can make this big. And then, okay, so starting with uploading the data. And we'll take a look at the raw text. So the next thing, it's going to connect to a Neo4j endpoint, and we will look at the extracted graph form. So we're going to ask it questions here. We're going to see it do its thing. So we'll see the answer streamed on the screen. So interestingly, this takes about 45 seconds. So there you have it. So we have got a lot of great partners. So we started in April, as I said, we started with 14 partners, and I believe there are 47 now, all different types of partners. Still looking for people to partner, and that's in amplifying what we're doing, contributions, as you can see, building out different examples. There's so much to do. OPEA 1.1 is going to drop, I think, next Friday, if they're exact. But lots of cool stuff coming up, lots of enablement on AMD hardware, which is very cool. And as you can see, the GraphRAG is definitely in our sites. We have that one example, and then we'll have more from Neo4j directly, which is really, really sweet. And I just have one more slide here, which is about which you can take a picture of. Like I said, we're looking for partners, we're looking for individuals. There's lots of different things to do, as you know, with open source. Lots of documentation needs, lots of work in making ideas real through the working groups, and definitely looking for all new examples. Like I said, we're doing the GraphRAG stuff. We're moving more into agentic AI. So would love to see you as part of the community.